Right, this is exercise 2e, and we're looking at inverse functions again, and in particular when inverse functions exist. I'm going to look particularly at graphs here because there's a little trick that we need to know. So it says here only one-to-one functions have inverse functions. Let me just explain that in terms of graphs, because I do think it helps if you look at graphs. I'm going to draw a graph of a function. I don't know what it is, whatever it is, and this one does have a an inverse function as well. So the basic thing we look for a number that goes in and a number that comes out of it. So if say I put in 2, I might get 5 out of this, and therefore if later on I wanted to go backwards, I wanted to find the inverse function, you can see I'd go, well, if I start with 5 and go backwards, I'd get back to 2. So it's a clear one-to-one link between the number that we started with and our answer, and then if we want to go from our answer back to the number we started with, it's obvious which one. Now that might seem obvious, but of course some functions don't look like that. So I'm going to draw a function that might look like this, more complicated function. Now this function, let's just draw a couple of axes properly on it. For instance, you'll notice this number here, I kind of get it in 3 places actually. And if I was to draw a horizontal line across here, then you can see that, I don't know, at 0, maybe at 2, and maybe at 3, all 3 of these numbers are given the same output, and I'm going to make this number out. This equals 1, okay? Positive 1, to get rid of that confusion. And so all of these numbers, 0, 2 and 3, as inputs give me the same output. Now if I was then to say, well, okay, let's go backwards, let's find the inverse of this, I start with 1. Well, it's like, well, which one is it? Do I go from 1 to 0, or do I go from 1 to 2, or do I go from 1 to 3? Can you see there's multiple choices as to where I started. Here I put 2 in, I get 5 out. If I then say, well, okay, I've got 5, what was my input? Well, it's definitely 2. But here if I say, well, I've got 1 as my answer, what was my input? Well, it could have been 0, could have been 2, could have been 3. All 3 of these answers gave 1. And so this, what we call this a horizontal line test. So if you can draw a horizontal line, that basically means it's not a one-to-one function. When I say a horizontal line that hits in multiple places, and here it hits 3 times, then it's therefore no inverse. That's what we're looking for. So just bear that in mind. So is it one-to-one? Can we draw a horizontal line? Look out for this. So my first question says, find the largest value of k such that f of x is x minus 3. So my very first thought is, I'm going to draw this. So x minus 3 all squared, it actually looks something like this. Not my best graph, but not bad. This is x minus 3 all squared. My God. And it says, all right, now just notice this up here. It says x is less than or equal to k. It wants me to state a domain where x is less than or equal to some number so that it is one-to-one. So, for instance, if I know that's 3 here. If I was to pick 5, pick that randomly, you can see that then it's got, at the moment, it's got these 2 places where it crosses, and if that was a bigger number, I don't know, 8, it would still have 2 numbers. So I need to restrict, I basically need to get rid of all of this bit. And for that reason, I reckon that if x is less than or equal to 3, i.e. k is 3, then this suddenly is one-to-one, because by getting rid of the right-hand side of this graph, I've only got the left-hand side, and now I can look at it and go, you know what, yeah, I can't now draw a horizontal line. It only now hits here because I've got rid of this side. So that's what I mean when I say a horizontal line. If I can draw a line that goes sideways and it hits in more than one place, that's not going to give me an inverse. Now for this value of k, find inverse. All right, and find the inverse. All right, and so I'll write that again. Y equals x minus 3 all squared. Move the square root over, or the square root becomes a square root. And one thing you've probably not done before, normally of course this should be written plus or minus. In previous examples I've said to you, oh, we're just going to pretend it's the plus version. But this one, because we've taken the left-hand side, I think we've got to take the negative square root. Otherwise, it won't work. So that's the negative because we've taken the left-hand side. I'm going to now move the 3 over here. That gives me 3 minus root y equals x. And don't forget we have to then rewrite it. F inverse, that's this bit, equals, and I'll get rid of the y's, I'll write x. So I got 3 minus root x. Okay, that's good. I've now found the inverse. And it says state its range. Right then. State its range of this function. Now you could just look at this function and think to yourself what this looks like. I will do that actually. I'll just draw this function. This function is a root x graph. Now a root x graph does that. It's a minus root x graph, so it does that. Plus 3. So I've got to move it up. So it actually does this. It starts there at 3, and that's the graph. And if I was looking at its range, it's all numbers lower than that value. So I'm going to write down the range is y belongs to the real numbers, but y is less than or equal to 3. Now one thing you'll notice actually is very similar to what we started with. And that's a consequence of what we saw in the last video. The domain and the range, if you know them of f of x, do you remember that thing that we saw? We saw it best saying the domain was the same as the range of the inverse, and the range was the same as the domain. And so you can see that here, the domain was x is less than or equal to 3 of my original function. The range of my inverse function is the same. Well, just a different letter, but you can see it's essentially the same. My answers are there, done. So x is less than or equal to the inverse. So I wrote that as y is less than or equal to 3, but other than that, it's the same. Okay. Right, what's this question say? It says, example, what is the inverse function of f of x equals x squared minus 3, where x belongs to the real numbers? Notice the domain actually hasn't been restricted. It's just all numbers. So if I was to draw the graph of this, x squared minus 3, well, that actually looks like this. It's a U shape crossing at minus 3. And for that reason, I don't think it's got an inverse. So these are, well, see, these are 3 possible solutions. Well, I already know that this hits in 2 places. Because I've not restricted it, my horizontal line test hits in 2 places, therefore there's no inverse. It doesn't say to me I can restrict the domain, so therefore there's no inverse. So look, the algebra here is fine, but it's wrong because there isn't an inverse function because it's not one-to-one. Likewise this, plus or minus. No, can't be right because it's not one-to-one. So solution 3 is the correct answer, not one-to-one, so no inverse exists. That's what I said. Now for this, it says, for the function shown in the diagram, so quite an interesting diagram, write down a possible domain of the form x is greater than k, for which the inverse function exists. Well, clearly at the moment, based on my horizontal line rule, I could draw, that wasn't very horizontal, I could draw a line across there and it hits in 2 places, and therefore this is not, that doesn't pass the horizontal line test, and that likewise down here it hits in 2 places. So I need to find the number where x is bigger than it, for which there is, right, so I think I just got to get rid of some of this graph. If I got rid of all of that graph, you can see the only thing left now is this little bit. Presumably that carries on forever, even though you can't see it properly. But yeah, I reckon, okay, that seems to be 3. So I reckon if x is greater than, or it says greater. If x is greater than 3, I think then if I was to draw a line, it would only hit there. Because all this other stuff doesn't exist. I think it's greater than 3. X is greater than 3. There you go. In this question, you must show some detailed reasoning, which basically is a posh way for the exam question to say, show some algebra. So I've got this function, which is a bit more complicated than we're used to. And it says and it's got some restriction. X is greater than or equal to 0. Prove that f has an inverse function. Now, something I've not shown you before, this blue box says a standard way to prove a function is one-to-one is to show that it's increasing or it's decreasing all the time. So here's the graph of this function, and just looking at it, I can already see that it never comes back on itself. Can you see that therefore is not one-to-one? Sorry, it is a one-to-one function because it doesn't curl back on itself there. Therefore, I've not run into problems of is it an inverse or not. So how do I prove this algebraically? Well, I use differentiation. You might remember doing increasing differentiation, increasing functions and stuff. Now notice this is not the inverse function. This is different. This is like dy by dx. And if I differentiate, I get 2x. Remember, I'll bring the power down and multiply. 3 over 2 times 8 is 12. So that's minus 12. Drop down the power to the half plus 18. And I need to show that this dy by dx, this f dash of x, is increasing or decreasing. So, I mean, to be honest, it looks like to me like a disguised quadratic. And let's just write y equal to, as a dummy variable, as to the x to the half. And I reckon, therefore, that f dash x is equal to, I'm going to write 2y squared, if you remember doing this, minus 12y plus 18, which I can take 2 out as a common factor. I get y squared minus 6y plus 9. And the reason why that's so useful is I can write 2 lots of y. Actually, this factorized, this is y minus 3 times y minus 3. So you can spot that, or you could complete the square and do the same thing. And so this is therefore telling me that the gradient f dash of x is equal to 2 times by some squaredy thing. And of course a squaredy thing, y minus 3 squared in this case, is always positive, can't be negative. So this must be greater than 0, or equal to 0. Therefore it's always increasing. This is an increasing function, that's our rule. So if you can't remember that, perhaps you might need to go back and look that up. Because it's an increasing function, therefore it's got a one-to-one function. There you go. And that's the posh version of it. A note about gradient. I want to, it says use differentiation and have a look at gradient. So I've got a couple of minutes to do this. When I'm going to find f dash of x, it wants me to differentiate, and it's quite an easy differentiation. It's 2x. And it says find this at x equals 3 over 2. Now this is 3 over 2 is 1.5. It's there. It's actually about there. Now that matters because if I write x equals 3 over 2 and I chuck it into my function and I square it, I get 9 over 4 plus 2, which is, I reckon it's 17 over 4. So I wrote that badly. Y equals 17 over 4. Now this matters in a bit. Well, anyway, so I now know that f dash of x is 2x at 3 over 2. If I do 2 lots of 3 over 2, it's 3. Okay. Hence find the gradient of f inverse x. Now notice this is f inverse, not f dash. So f inverse is this graph down here, and I've actually already found what it is. It's root x minus 2. And we want to do it, this is a number that's appeared before, that's 17 over 4. And you'll notice 17 over 4 is about there, which is in line with there. And because of the symmetry of this graph, there is a rule that basically says the gradient of the original graph, if it's m, at a comma b, at b comma a, it's 1 over m. The gradient is 1 over m. Now, I found that the gradient here, m, was equal to 3. So I reckon here I can write m equals a third for this bit. Yes, that's what it is. So have a look at that. You might need some working out what's going on. So exercise 2E now. This is the last thing, and there will be a homework on functions appearing online as well. Good luck.